Friday I left you with trying to copy the orange drive rail into that project we were working on, and that was going to be a pretty good exercise. But since then I've decided that it might be a little better off to build our drivetrain more like a competition season, and we'll keep on exploring the tools as we need them. So if we go ahead, our goal is to eventually get to this point right here, building a drive base here and make it completely dynamic so we can at any time change the size of our robot by going into an initial sketch and say we want to make a 25-inch long robot. .25 by 25 this robot would be, hit and finish. And you see now our robot changed dynamically. Everything stayed the same. All rails were cut to size. We could also put it back to our 2020 robot size of 27.5 at 32. We now see our robots back out to the normal size, but just changing a few parameters. So I'd like to go ahead and show you how we're going to get there and have you start working on this path versus the stick building path that we were kind of going down before. Let's start off by starting a new project here, and we'll go ahead and save it right away. And I will go pick my folder. I'm going to name this drive train. That's the nice thing about Fusion is you can have objects that are named the same, and it won't complain too terribly much. So how I got there in the beginning is starting a new sketch. Remember we said rule 1 is always start with a component, but we're going to drive all of our components off of a common sketch. So there's two ways we can go there. We could go ahead and start adding our components that we know we're going to have, saying left drive rail in the main. I'm going to leave that unactive for now. I'm going to add some components here. Right drive rail. Front drive rail. Rear drive rail. Front bumper mount. Rear bumper mount. we have a bunch of components declared, so to say, but I'm going to draw in this particular sketch up in the main, so all these components can be driven off this sketch. So having the source of the tree currently active, I'm going to start a new sketch. I'm going to sketch it on the top plane. And I'm going to start out with just drawing some basics rectangles. I'm going to go ahead and pick the center point rectangle just so some constraints get automatically locked in. And here's where we can define the overall perimeter of the robot's going to be. I'm going to switch this over back to imperial units. I'm going to make a couple dimensions here. Well, no, I don't even do that. Make some lines. I'm going to draw a basic line here to create our front and rear bumper mounts that we know we're going to need. And I'm not worried about sizing it. I'm going to label that later. Next, I know since we do chain and tube, I'm going to draw our left and right tube, and we know the ends want to be open to the outside. You can see I'm allowing the automatic constraints to kind of snap in place. And finally, we're going to have our frame, front and rear frame. Once I have the generalized robot tubes drawn and our wheel wells drawn, I'm going to go ahead and start adding some dimensions on here. We know our robot in 2020 was 32 inches long. 27.5 inches wide. The bumper mounts were 1 inches. Also 1 inch. Frames were 1 inch. Our wheel wells were 2 inches deep. Front rail is on the 1 inch. Bumper mount 1 inch. 1 inch. This is generally our robot we had. We had our front and rear bumper mounts made out of 1x1 tubing. Our side rails were made out of 1x2 tubing, going the full length, and then we had those cross members. With those sketches done, I'm going to hit finish sketch. And now we know the front of the robot's right here. So with this being the front, this will be the right drive rail, this will be the left drive rail. So I'm going to activate the left drive rail. And that sketch is now active. Now that the left drive rail is activated, I can extrude this square. And since I snapped it to the origin, I'm going to grow everything symmetrically in two directions. I can choose the whole half length or the whole length. Half the length is going to be 1, giving us a 1x2 piece of tubing. I'm going to create new body. Hit OK. You see our sketch went away. If we go back up to the sketches of the main and turn that back on, the sketch will remain on. I'm going to pick the right drive rail. I'm going to activate it now. I'm going to extrude the right drive rail using the same steps. Symmetrically, 1x1 or 2x1, new body, OK. I'm going to repeat these for the front. Activating the front drive rail, extrude, symmetrically, distance of 1, OK. Activate the rear drive rail. I'm going to type E for extrude, shortcut key, 1 inch, symmetrically. Now for the front bumper mount, I'm going to do similar. I'm going to hit extrude, or E for extrude. This time I won't need to do symmetrical. We used a 1x1 tubing and it was slid to the top of the tube. Let's leave it as that. New body. Activate the rear bumper mount. Extrude. One inch. Why didn't that's quite slack there? Grab from the top. Extrude. 1 inch. Okay. Now you can see, if I go back to the top level, we have all of our frame members. We're all done with the sketch, so I'm going to shut that sketch off. And now we have these solid blocks. Now we have to convert them into tubes. Yesterday we did two ways. We drew a sketch with the wall thickness on there, and we also used a tool called shell. Here I'm gonna run these shells in the top level of this, so I can shell multiple bodies at one time. We could go into each rail and shell each individual one, but you'll see here why in a second, where I'm going to stay in this top level to perform these shells. So first thing I'm going to do, I'm going to shut off these front and rear bumper mounts just to get them out of the way for now. I'm going to select the faces of my two drive rails, and only the two drive rails this time. Spin around to the back. Pick a wall thickness, 0.1. Now the reason I'm doing these separately is there may be a time where we want different thickness walls on these two rails, and since they're going to be symmetrical, they would likely be the same. I'm going to hide the front and rear so I can see the ends of the left and right. So I can see the ends of the front and rear tubes. I'm going to repeat those steps. Picking shell, choosing the ends of each tube. This is where I could pick a different thicknesses. We used 0.1 100 thou tubing here, but there's potential we could use the 50 thou tube for weight purposes. There. Turn those back on for we can see. And finally we're going to look at our bumper mounts. And here again, that's why I'm still up in the top level of the project. Hit shell. Pick the faces of these square tubes. Wall thickness, we use 100 thou. Currently, right now, all the tubes are shelled and has tubing, but they can still be moved around. Undo that move. We could use joints to joint that all together. We haven't defined where all of our holes are going to be or where all our brackets are going to be, but and we know this is always going to be a rigid mount. One of the joints that we can use, and it's a little easier on the computer for computing, so we highlight all the objects, assemble, and do a rigid group. Okay. Now they all move together. Let it go snap back in here though. I want this frame to stay relevant to the origin, like it was originally drawn. Since we drew it symmetrically, so this is the dead center of the robot. I'm going to try to leave it that way. All I have to do is go ahead and pick one of these objects here, right click on it, and ground it. Now all these objects are stuck because this one is grounded and the rails cannot move. We can add color later, but to help us kind of visualize what's going on here, we can start adding some color, add some physical materials. I'm going to add some paint to it right now. orange isn't in here right away. The blue is. I'm going to download the blue. This tube was blue. That tube is blue. Duplicate the color. Edit the color. Slide it more into the orange. And now I can make these other tubes orange as well. You can see now though how powerful this is going to be. We have all our tubes defined, and we can change the size of our robot very easily by simply going to this top level sketch. And we can make a 10-inch wide robot. Our wheel wells have to stay the same. Everything has to stay the same. The length changes. So let's get to that point here together. And if you want to go ahead and move ahead, you can start to look at putting some of the gearbox holes into the robot as well. I'm going to stop it there for now until we do meet again.